All right, now that we have an idea of what the sampling distribution is, we can do hypothesis testing. Okay, so the core concept of hypothesis testing is going to be exactly the same for population variance as is with the population mean. Right? We have three types of test: lower tail, this is the left tail, two tail test, or the upper tail, right tail test. Okay, and okay, and then so we would use a critical region, or sorry, we will use a critical value approach, or the p-value approach. Again, this both of these are the both of these are the same. Right now, so sigma square, that is a hypothesized value of the population variance. Okay, and the test statistic is calculated using the symbol chi-square, right? And with n-1 sample variance, that's the observed, divided by the hypothesized, the null variance, or the null hypothesis. Okay, and then it will have a chi-square distribution. All right, now let's go back. Let's use our example that we worked on already. Here again is a thermostat example. I have the same exact data set. So look at your previous page. We can write down our sample statistics is n equals 10, and our s, right, our standard deviation, or sorry, I should just go to variance because we're doing the test on the variance. Our variance is 0.7. Okay, all right. Now, so read the question a little bit. We're changing the question a bit. Now, we are saying that if the temperature variance is 0 0.5 or less, then it is acceptable. Okay, so let's set up the hypothesis. Now, how would just think about it? How do you think the hypothesis should be set up? We have sigma square, and then we have 0 0.5. I'm leaving the inequality here a bit. 0 0.5. Okay, all right. Now, so how should for the null hypothesis, how should the inequality be? Right? Now there's some ambiguity here, but I think by the way we're reading this, the goal here is to accept. So the keyword I'm looking for is to accept. Right? The keyword here is the goal here. Sorry, is to accept the hypothesis that the variance is less than or equal to 0 0.5. I think as long as we don't reject this hypothesis, then the thermostat is deemed okay. Quality is acceptable. Okay. Okay, and so now I'm going to, so then the alternative is going to be greater than 0 0.5. Now let's identify the rejection region. So this conceptually, again, is going to be very similar to the normal distribution. Instead, I have a chi-square distribution. Now this is a one-tail test. So one-tail test, and same, this is a right tail. So my right tail is here. I'm going to go ahead and shade that. So the area in the tail here is alpha. Okay, what's my alpha? Oh, I'm looking at alpha of 0 0.1, 0.10. Okay, so my chi-square alpha, right? So that is going to be, okay, and before I do that, I need to know the degree of freedom. The degree of freedom for this distribution, chi-square, is 9, right? n-1. And here is going to be my acceptance region. Right? And then here is my rejection region. Right, rejection region is going to be in the tail over there. Okay, so again, I want to find the chi-square distribution. Right, go in here, 9, and then, oops. Okay, my tail is 0 0.1. Okay, now this is the right tail test, and here we go, 14.68. Okay, so now I have a critical value to compare. Now I have a critical value to compare my test statistic against now, and so and it's the same as before. I mean the population mean, right? If my test statistic, right, is greater than 14.68, I will reject the null hypothesis. If it's less than, I will accept the null hypothesis. My test statistic. Okay, so just look up above. That's how we'll calculate it. Right? Is n-1 s squared over sigma square of the null. So in this case, it's going to be 9 times 0.7 all over 0.5. Put that in the calculator, and what you should get is 12.6. That's my test statistic. Okay, so here we go. Our chi-square then, it is less than our chi-square critical value alpha, right? 12.6, it is less than 14.68. Therefore, we accept the null hypothesis, right? We do not reject. Okay, all right, and then we can say that we can conclude the test that that there is no evidence to suggest that the variance is greater than 0.5. Right? We did not reject our null hypothesis.